In this recording, we're going to look at the locus definition of a parabola. You'll have to pardon my voice, it's not 100%, but I thought it was worthwhile to record this video because the one I had from the previous year was a little confusing. I think I can do a better job simplifying the concept here. You remember back from geometry, we had a locus definition of a circle. All points are equidistant from that center. Parabolas have a similar idea, but it's a little more complicated. And here's the definition. A parabola is all the points that are equidistant from a fixed point called its focus and a fixed line known as its directrix. Let's try to envision what this looks like. You've seen these satellite receivers. Sometimes they're on the side of houses. Up in space, there's a satellite sending a wave that bounces off this parabolic curve, the satellite dish, in such a way that when it hits the dish's edge, it gets reflected to the focus point, the receiver. And no matter which one of these pink lines we follow, they all get reflected back to the receiver. Okay, this is called the focus, and that's the parabolic design of this satellite dish. Let's see what this looks like with a little gizmo. Okay. We have this gizmo where we have a parabola centered at 3, 2. You can see down here the vertex form, shift to the right, shift up 2. 3 to the right, up 2. That's no surprise. Our question is, where does this 1/4 come from? Well, we've got a few new features here. We've got the parabola's focus, which is here at 3, 3, and its directrix, which is here at the line y equals 1. I can click on this little box to show that the distance between the focus and the vertex is 1, and then from the vertex down to the directrix is also 1. Anywhere I move a point on the curve, on the parabola, these pink or purple lengths are the same. You can see right here it's 5.2. If I move it over to the other side, it stays the same. There's the same distance between the focus and the vertex as well as the directrix and the vertex. All right. But here's the point I wanted to make. As I change the focal point, it moves the directrix in an equidistant amount. Check it out here. I remember how there was a 1/4 used to be the coefficient? Well, now that the distance is 2, I have a 1/8. If I make the focus and vertex 3 units apart, we now have a 1/12. Okay? I think you can see what's going on here. Make a prediction for what would happen if I extend this 5 units from the focus to the vertex. Okay? Hopefully you are recognizing it's 1/4 times that distance. And it really doesn't matter if we have a parabola that's concave up or concave down. Okay? Obviously, concave down, you're going to have a negative a value, right? But we have still, whatever this distance is, 1/4 times that distance. Cool. Let's use that information to solve a couple of problems. Okay, so let's just summarize what we've learned so far about focus and directrix. Okay, we'll make ourselves an axis. And let's sketch a parabola here down in quadrant 4. And we'll call this the vertex. It's common to use the letters H and K to describe the vertex coordinates. And let's name this the focus right here. And let's go equally distant. So that same distance from the vertex to the focus, we want to go from the directrix to the focus. Okay, so that's our horizontal directrix. And let's just label this distance. It would help if you had some colors to label the different parts. So this is D, the distance from the focus to directrix, excuse me, from vertex to directrix, and distance from vertex to focus is the same. And over here we can say that A, well, remember, A could be positive or negative. The distance is always positive. So A is going to be 1 over 4 times that distance. And let's remind ourselves where A is. A is the coefficient here that describes the vertical stretch, vertical shrink. Okay, so let's do a couple problems. I'll give you a chance to write down this question. Pause the recording until you have written it down. Okay, hopefully you got that written down. Begin with sketch. So that's easy enough. We know how to sketch. Okay, I don't want to take your thinking away. Why don't you sketch where that focus and directrix are, and then plot where you think the vertex is, using your understanding of their relationship. Play with the recording when you're ready. Okay, let's see how you did. All right, so that's our focus. I'll label it F. That's our directrix, the line y equals 3. The vertex has to be equidistant, so I'll just kind of think about what's the difference here. I've got from 1 all the way down to -3. That's 4 units. So therefore, it should be the same distance. So that means I've got a distance here of 2. A distance here of 2. Well, then I can easily figure out what that coordinate is, right? So I can find out what the coordinates of the vertex. I'll label it V, 5, comma, -1, right? It has to be lined up vertically with the focal point, and I just have to find the average between 1 and -3, the middle of them. All right, now comes, how should this parabola go? Would it make sense, don't draw this, would it make sense for it to go like this, or this purple one? Well, hopefully you're saying it can't be the green one. It always wraps around the focus. Remember, the parabola wraps around the focal point. It never goes through the directrix. That wouldn't make any sense. So let's get rid of our green one, and just draw a nice, smooth purple one here. And it doesn't have to be perfect. We just need it to wrap around the focal point, like so. Now we just have to write our equation. Well, we can start out by figuring out what A must be. The absolute value of A is 1 over 4 times D. Now we just need to figure out if A should be positive or negative, and I know you know it should be positive, right? It's concave up. So therefore, A equals, and let's just say what the A value is. 1 over 4 times D, 1/8, right? Where D is 2. So now we've got that piece. Now we can just write the equation in vertex form. So pause the recording and write out that equation. Play the recording when you're ready. All right, so hopefully you wrote your equation. Got our A value. And then our shift right 5 units and down 1 unit. All right, so there's our equation. Now in our last example, we're going to look at a form that is a little unfamiliar. This is our vertex form. This is a form that's unfamiliar, but it's the same information. Just realize that the y is not isolated, okay? So it's like they got rid of the fraction by, you can see how if I were to do work on this, it would be like, get rid of that little smudge there. If I were to do work on this, it would be like subtracting 2 from both sides. All right, so I'd have a y minus 2 on that one side, and then multiplying both sides by negative 16 to undo the fraction on both sides. So we're going to be given a format here that I'd like you to write down, and then I'd like you to find the vertex, focus, and directrix for the parabola described as such. Go ahead and write it down, then we'll work on it. Okay, so hopefully you had a chance to jot down this question. First off, we have to get it in a form where we can start recognizing things. So, well, I'm going to first off divide by negative 12. So the first thing we're going to do is divide both sides by negative 12, because we're trying to isolate the y, right? We're trying to get it in y equals form. You can imagine there's like a 1 here as the coefficient. Now we're at this stage, okay? So we have 1 divided by negative 12, or negative 1/12 as the a value. I want to get y by itself, so of course we're going to subtract 1 from both sides. That should look like a familiar form here, right? We can see it's in vertex form. So you can see what the vertex is. I know you're familiar with the horizontal shift and vertical shift, but what's the a value here? Okay, and what does that tell us about the d, the distance between the focus and the vertex? Hopefully you recognize that 1 over 4d means 4 times 3 equals 12. So 3 would be the d value. Sketch yourself an axis, and I'd like to see if you can set up where this vertex is of this parabola, and then what that can tell you about where the focus is and where the directrix is, based on your d being 3. Play the recording when you're ready to see how far you got. Okay, so hopefully you took time to make a sketch. You got your vertex in place at 4, negative 1. Hopefully then you realized, hey, 3 up and 3 down from the vertex are going to show me where the focus and directrix are. Of course, I got to really do some thinking to think about if it's concave up, concave down, and what that's going to mean about which one of these is the focus and which is the directrix. Of course, it's concave down, right? Because a is negative. So I know I'm going to have a situation like this where it's going down. That means it's wrapping around the focus. Focus keeps the same x coordinate, but the y is down by 3. And if I go up 3 from negative 1, I'm at y equals 2. That's our horizontal directrix line. And now we have all the information we need. So let's just write down the answers. Our vertex, our focus, and our directrix. Thanks for watching.